In this video, we will derive a formula for Bernoulli probabilities. So recall that in the last video, we worked out that when we had 4 Bernoulli trials, we found the probability of there being 2 successes, and the general formula we had was 6p squared q squared. Remember, p was the probability of a success, q was the probability of a failure, so we needed 2 successes and 2 failures if there were 4 total trials. And then the 6 came from all the different ways that we could order those successes and those failures. And we did this with a tree diagram. So our goal for this video is to be able to count this more quickly. To have a more efficient way to do this than always having to draw a tree diagram. So let's begin by labeling S as a success and F as a failure. So what we want now is there are 2 of these S's and 2 of these F's. And we want to count the number of ways to rearrange these. So count number of ways to rearrange these. So in the last video, we did this manually by drawing a massive tree diagram that took a lot of time. It would be nice if there was a quicker way. So I could start to list some of these, like SS, FF, if I put my 2 successes first, or I could do the failures first and do FF, SS. I could alternate and do SF, SF, and I could keep going like this, so I'm just going to write ETC for the time being. But one thing I want to notice about all of these elements in this list is that each of them has the same probability. Each has a probability of, so the probability of a S happening is P, and there's 2 of those S's, so that we'll get P squared. And the probability of an F happening, we've called that Q, and there's 2 of these F's, so we get Q squared. So it's just a matter of now determining, well, how many of these rearrangements of 2 S's and 2 F's are there? All right, so the way we can think about this is to suppose that we have 4 slots. So slot 1, slot 2, slot 3, and slot 4. And let's think about what our strategy is going to be. So for our strategy, there's going to be 2 steps to it. I'm going to sort of place the S's, the successes, and then place the failures, the F's. So we need to first choose 2 out of the 4 slots to label with an S. So maybe that's this one and this one, or maybe it's the first one and the third one, but we got to choose 2 out of those 4 slots to label with an S. And the order in which we do it doesn't matter. So we're going to use combinations. So we're choosing 2 of the slots, which means I put a 2 at the bottom, out of the 4 total slots we have, so 4 on the top. Therefore, choose 2 ways to do this. Okay, but after I decide where I'm going to put my S's, now I'm on to step 2. And the remaining slots get labeled with an F for failure. Okay, so if I had put the S's in those 2 positions, that would mean, well, there's only one way to put the F's, which would be in whatever's left. I'm forced to put the F's there, so there is just one way to put the F's in after I've already put the S's in. Okay, so let me justify that. So we can only put the F in what's left Okay, so this was just a hypothetical scenario where I'd put the S in the first spot and in the third slot. But I could imagine that even if I'd placed the S's in a different way, once I place the S's, there's only one way to put the F's down, which is put them in the blank spaces that are left over. All right, so that said, we are now ready to write down the probability that 2 out of 4 of our trials are successes. 2 out of 4 are successes. So to do this, we need to count the number of ways to have 2 S's in these 4 trials. So 2 successes in 4 trials. And then for each of those, I need to multiply by the probability of each outcome, which we had already stated. The probability of each of these rearrangements was exactly the same. Okay, so for the number of ways, it's just 4 choose 2. I could technically multiply by 1, but that won't really affect things. And then now I have to multiply this by the probability of each outcome. So the probability we had said on the previous page, it was p squared times q squared. P squared because p is the probability of a success and we need 2 of those successes, so that's p times p. There's also 2 failures, so we get a q times a q. Alrighty, and if I simplify this, 4 choose 2 times 1 ends up being 6. And that is the exact same thing we got in our last video, 6 times p squared times q squared. 6p squared q squared. Okay, so let's generalize this to get a formula. Okay, so in general, suppose that we have n trials. So if I have n trials, I'm going to draw n slots. So slot 1, slot 2, slot 3. I'll put a dot, 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 because I don't know exactly how far to go. And then this is going to be the second to last one, and the very last one, slot number n. So overall here, imagine we have n of these slots. And now suppose I want to have k successes. So suppose we have n trials, and we want k successes. Then we are going to choose k. Let me write that better. Choose k of them to label with an S for success. Okay, so now we are ready to write down the number of ways to have k successes in n trials. It's just going to be a combination, because the order in which you put the S's down doesn't matter. So we got to choose k of the spots to put an S into. And there are n total spots. So we write an n on the top. So we have n choose k ways to have k successes in n trials. And each of these is going to have the exact same probability. Let's see, that we're going to have a bunch of successes. So we put a bunch of p's multiplied by each other, and we'll get p to the k, where k is the number of successes. And then we'll multiply this by q. Q is representing the probability of a failure happening, and I have to think about, well, how many failures am I going to have? If there's n total trials, and k of them were successes, that means there's going to be n minus k failures. N minus k failures. So this is the number of failures. So putting this together, the probability of having k successes in n trials involves multiplying these together. There are n choose k ways to rearrange these k successes in these n spots, and each one of them has a probability of p to the k times q to the n minus k. So I'm going to highlight this. This is a key formula for this section, for the probability of having k successes in n trials. So this is when I have a Bernoulli process that I repeat many times. I'm repeating it n times. So I would definitely encourage you to pause the video to really go through this at your own pace, especially if this is a little bit quick, to really make sure you understand where these different items are coming from. That is really important. All right, in terms of our goals now, we finished our second goal, which is to derive a formula for the probability of a Bernoulli process. By the word process, I mean when we do a Bernoulli trial a bunch of times. So over the next few videos, we are going to do some examples.